Hi, everyone. Thank you for being here. My name is Simone de Santis. I'm the CTO of Openapi.com. Today, I'm not going to give you a typical architecture talk. I'm going to tell you a story, our story. It has a fire, some expensive mistake, and a promise, and a happy ending. Let me start with a question. What happens when your data center is on fire? I don't mean a metaphor. Real flames, real smoke. 5 years ago, this stopped being an hypothetical question for us. And one specific night. And the honest answer, one of the questions changed almost everything about my team build and run software today. I want you to tell this story the way a movie tells story, as a hero journey. A hero lives an ordinary life. Something forced them to leave it behind. They face trials they didn't choose. They meet mentors along the way. They almost fail more than once. And eventually, they come home changed, carrying something valuable enough to share with others. This is essentially what happened to my team and to me. I'm the CTO who lived through every stage of it, from the first phone call about the fire to where we stand today. Today, I'm not going to give you a polished highlight reel. I want to share the scares, the paranoia, and yes, the bill, so that you don't have to learn every one of this lesson in the expensive way like we did. Here's the map for where we're going today. We start in our ordinary world, a private cloud that felt safe and stable. Then disaster strikes without warning. Then come a first attempt to fix things using tools we already knew. And it turns out to be a very expensive attempt. We meet our mentors. We cross threshold into real cloud-native architecture. We survive a series of trials, each one harder and more specific than the last. We win a genuine reward. Then, and this is the part almost nobody tells you in advance, winning bring a whole new set of problems. And finally, we return with the lesson. Every hero journey starts in an ordinary world, and ours looked pretty comfortable. We had physical hosts running in our private cloud. We had backups, real one, tested one, not checks in a compliance form. And we were not living in the Stone Age. Part of our infrastructure was already as microservices. On paper, we were in generally good shapes, stable, predictable, boring, even safe. I want you to hold on that feeling for a moment, because it's exactly what disappeared in a single night. And then the disaster. A fire broke out in our data center. Not a joke, not a drill. A real fire that destroyed our physical server. The actual machine gone. That alone would have been a serious problem, the kind you can usually recover in a few painful days. But here is the part that really hurt. The fire destroyed our backups too. The safety net we trusted, the thing that existed, and exactly this situation gone. In the very same event, the hero's journey, there's a moment where the hero's world is destroyed, and there's no path back to how things were. For us, that moment was very real and very literal. We were at zero, completely. Every line of code, every configuration, every safety net we thought we had, gone in one night. I still remember getting that phone call. When you are in survival mode, you don't redesign everything from scratch. You reach for what you already know how to do, as fast as you can. So we rebuilt from zero using the same paradigm we had before. Virtual machine, server, we configure and manage ourselves. The same mental model we had used for here. The one real difference was where it all lived, not in our own data center anymore, but at a major hyperscaler. And honestly, it felt safe precisely because it was familiar. What we learned very quickly and very painfully is that it was also the most expensive option available to us. Every hero at some point need a mentor, someone who's someone like Gandalf, okay, who has already walked a version of this path. Howard arrives in the form of an external consultant, and to their credit, they didn't just come in and fix our infrastructure for us. They changed the way our whole team thought about it. The starting point was Terraform. Instead of clicking through Cloud Console and configuring servers by hand, one at a time, we began describing our entire infrastructure as code, version controlled like any other software, reviewable by teammate before it ships, and fully repeatable on demand, every single time. It sounds like a small technical detail on a side. It was not small at all. Over the following year, infrastructure as code became, without much competition, the single most valuable asset of our engineer organization own. More valuable than any individual server, any individual service, on any individual piece of application code we had written. Everything else in this story gets built on that foundation. With Terraform underneath, as a foundation, we made a decision with no way back, a complete refactoring of our systems, and the genuine cultural transformation alongside it. We were leaving traditional system administration behind for good, stepping full into DevOps mindset. This is the moment in every hero's journey where the hero crosses the threshold, where they leave the familiar world behind completely, with no easy way to return to it. For us, it meant that every single assumption we had ever made about server, our capacity planning, and about cost was about to be questioned one assumption at a time. Refactoring sounds clean and simple on slide. In reality, it meant facing almost philosophical decisions, one right after another, often with no clearly correct answer. The first big one, which hyperscaler? AWS, Google Cloud, Azure? Each one represents its own philosophy, its own pricing logic, and its own ecosystem of tools and trade-offs. The second decision, right behind it, was which orchestration technology? Fully managed Kubernetes service, a cluster we build and run entirely ourselves, or a different approach? I'm not going to pretend there's one universal correct answer to either question. There is only the answer that fits your specific team, your existing skill, and your actual budget. We spent real weeks on just these two decisions alone, and we generally changed our mind more than once along the way. The next trial waiting for us was vendor lock-in. Every managed service you adopt makes your team faster today and just a little more dependent on that one provider tomorrow. There's no way around that trade-off. You can only manage it consciously. We had to decide service by service exactly how much convenience was worth how much dependency. And tied directly to that question was another hard one, data persistence. Containers are by design meant to be temporary. They can disappear and start at any moment, often on purpose as part of normal operation. So where does your data actually live, physical and logical, when specific container that create is already gone? Get this one wrong, and it doesn't cost you extra money down the line. It costs your data permanently. Then came a very practical, very physical trial, memory. Every single container carries some amount of RAM overhead, just to exist before it had done any real useful work at all. If your application is heavy and you want to scale it horizontally, and overhead multiply very quickly, and so does your monthly bill, also silently. So we had to optimize our own software at the code level, a smaller memory footprint, a faster startup time, and architecture designed from day one to run as many small, efficient containers side by side. This trial deserves its own name, scalability paranoia. On-premise, the challenge you face is fundamentally different. You distribute your workload carefully over time because your physical hardware is fixed and generally limited. In the cloud, your hardware is no longer fixed. It's practically infinite, on demand. Nothing technical stopping you, your system from scaling out of hundreds of instances in a matter of minutes. Nothing except your the configuration that you personally wrote. We had to master several things at once, under real pressure. Cold start, how long a brand new instance takes before it's actually useful to a real waiting user. An upper limit on instance. Deliberate ceiling so that a bug, unexpected traffic spikes, or even an attack cannot silently scale you straight into bankruptcy overnight. And correct instance sizing, making sure you never quietly paying for compute power you never actually use. After 5 years of this approach, here's roughly where we landed. Our infrastructure became genuinely cost-efficient, truly scalable, without the drama it used to involve. More secure. Our deployment became frequent, fast, and properly controlled, instead of chaotic and nerve-wracking. And for the first time in our company history, our infrastructure costs were actually aligned with real business value. We pay for what genuinely creates value for the business. We stop paying quietly for idle machines sitting around, waiting for work that might never actually arrive. In the movie, this is where the heroes come home, celebrated, and the credits roll. In real infrastructure work, the story simply continues. This new architecture creates its own set of brand new problems. Smaller than a literal file, sure, but very real and very costly if ignored. Let me walk through 4 of them one at a time. First, we need to forge our own sword. The generic framework available to us on the market were either too heavy in memory for our containers or too unstructured for dozens of independent team buildings, APIs on their own individual style. So we built a small micro framework optimized for low RAM usage that standardized exactly how every team at our company design and ship APIs. It's not glamorous work, it will never be open source, but it's one of the quiet and glamorous reasons our containers stay small and our monthly bill stayed low. Second, shielding. We learn how to use multiple layers of CDN, working together instead of competing with each other. Cloudflare handling one layer, Google handling another. Every single request that gets fully handled at the edge before it even reaches us is a request that never touches our expensive compute layer at all. It wasn't only a performance improvement for our user, although it was that too. Over time, it quietly became one of our most single effective tools for controlling monthly costs. Third, data. Database clusters are some of the most expensive things to scale in the cloud, and they simply don't scale as gracefully or cheaply as stateless containers. Our answer to this was simple to say and hard to execute well in practice. Cache aggressively everywhere it makes sense to do so. Every single request that gets served from a cache is a request your database cluster never has to fill and never has to bill. Fourth, rhythm. We had to build a real CI/CD pipeline from the ground up, adopted and learned to trust it completely, moving from manual deployment done late at night to a controlled, repeatable, almost boring pipeline was its own cultural journey. And boring, by the way, is exactly what you want a deploying pipeline to feel like. So, what we bring back from this entire journey, infrastructure as code, comes first, always. It's not an optional nice to have. It's the foundation that everything else in the story depends on. Designed for scale to zero, not for your load peak. On-premise thing optimized for fixed hardware you already own. Cloud-native thinking optimized for real, current, actual demand. Respect the blank check that autoscaling represents. Every single limit you don't set yourself, it's dangerous. Keep your container small and keep your API standardized across team. And cache before scaling your database. This was not a clean success story. It was 5 years of real scares, real paranoia, and yes, very some expensive lesson. But today, for the first time in a long time, my team and I actually sleep at night. Thank you for listening this to our story. I'm happy to take your question now there. Thank you.